Let's go ahead and take a look at our next example. A colony of bacteria grows according to the following model. N of t equals 90 times E. The exponent on that is 0.05 t. N in this case is being measured in grams, and our value for t is being measured in days. Let's determine the initial amount of bacteria. We're going to be looking for n sub 0, and we can do this one of two ways. We can plug in a t value of 0 because we want to know how much bacteria we have at time t, or in this case we can go ahead and get the number right off our model. Let's go ahead and take that second approach. Off our model, our n sub 0 value is 90. Part B. What is the growth rate of the bacteria? This is asking us about our K value. And notice in our problem, our K value here is something that is positive, so we know this is a growth model, and our K value here is 0.05. You could also write that as 5%. Part C. What is the population after 5 days? In this part of the problem, they are giving us our time value. T is going to be equal to 5 in this case, and we want to know what the final population is. So we're going to be solving for n of t. Let's go ahead and plug in the 5 for our t values. This is going to give us n of t, or the number after 5 days, equals 90 times e. The exponent on the e is 0.05 times 5. Now let's go ahead and use our calculator. This might be one of those problems where you want to simplify as you go instead of trying to type everything in all at once. So let's go ahead and simplify what we have. I'm going to go ahead and simplify this exponent to 0.25. Now let's go ahead and calculate this out with our calculator. After using our calculator, we get about 115.6. I'm going to go ahead and round that to the nearest whole number. So let's call that 116 grams of bacteria. Part D. How long will it take for the population to reach 140 grams? In this case, they're giving us our final amount. We want to have 140 grams when we're done. We are looking for the time. Let's go ahead and set up our equation. Now that we have our equation set up, let's go ahead and talk about how to solve for t. We want to get the variable t all by itself on one side. In order to do so, we're going to have to divide both sides by 90. I reduced my fraction on the left-hand side, but I still left it in fraction form. Now, I want to go ahead and solve this equation for t. In order to do that, I'm going to have to use logarithms, and there's no way for me to write 14/9 or e so that they have the same base, but since this base is an e, I'm going to go ahead and take the natural log of both sides. Now, when we do that, we can go ahead and use our properties to simplify this right-hand side. Our exponent is going to be able to come down in front and make that right-hand side into a multiplication step. Now, let's go ahead and simplify this natural log of e. Recall, natural log of e can be simplified to a 1. If I take 1 and multiply it by 0.05t, I'm going to get 0.05t on my right-hand side. And now if I want to solve for t, I can go ahead and divide both sides by 0.05. this is going to give me about 8.9 days. Remember to put units on these since you are working with word problems. The time piece, according to your problem, could vary, and it could be measured in hours or days or years. So make sure you're labeling your answers correctly. For us on this one, we have 8.9 days. And part E. How long does it take for the population to double? Remember that when we first started working with this problem, our initial population was 90 bacteria. If we want our population to double, we're going to have twice that many, or in this case, a final population of 180. And we want to know how long does that take. So we're going to be solving for time. Let's go ahead and plug in the pieces that we know. Now, just like the last part, we want to go ahead and solve for t, which means we want to get the t all by itself on one side of our equation. So let's go ahead and divide both sides by 90. Just like in our last problem, when we're solving for t, notice we're not going to be able to write 2 and e so that they have the same base. So I'm going to have to take log of both sides. Because the base of e is on that right-hand side, I'm going to go ahead and use natural log of both sides so that I can simplify my problem in the next step. After we take natural log of both sides, then we can go ahead and use our properties. I'm allowed to bring down my exponent, that 0.05t, using property 3. On our right-hand side, we want to be able to simplify this natural log of e. Remember, just like in the last part of the problem, anytime we see natural log of e, we can replace that with a 1. Now let's go ahead and divide by 0.05 so we can finish out our problem. Our final answer for this problem is about 13.9 days. That's how long it's going to take for our population to double.